All right, let's just dive right into this explainer. And hey, do me a favor, put away all those scary formulas for a second. If you've ever felt like math just keeps building and building, from numbers to algebra to geometry, and then suddenly you hit calculus and just feel completely lost, well, you are definitely not alone. It's really not because you aren't smart enough. It's usually because math classes just hand you a textbook full of symbols and expect you to memorize them without ever stopping to explain what the math actually is before throwing all those complex equations at you. So today, we're tossing the textbook out the window. We are going to learn about differentiation as if you were 13 years old again, focusing entirely on the very relatable real world.
So to really wrap our heads around calculus, we literally just have to look at the phones in our pockets. Let's say you're on the bus ride home playing a game, and your phone says you have 40% battery left. Does that 40% mean you can game for another 2 hours? Or are you going to be staring out the bus window in total silence in exactly 12 minutes? The 40% alone doesn't actually help you. What you really need to know is the exact rate your battery is draining. Knowing if it's dropping 2% a minute or 0.5% a minute is what really tells you if your phone will survive the trip. You care about how fast it is changing right now, in this exact moment.
And honestly, this right here hits the nail on the head. It illustrates the exact core problem that calculus was invented to solve. Regular math, the kind you learn early on in elementary and middle school, is great for things that stay the exact same. It's static. But our universe isn't static, is it? It is in constant motion. Prices change, temperatures fluctuate, rockets launch into space, and phone batteries drain. Calculus was built as the ultimate software update for mathematics. It is designed entirely for a world in motion. It's literally just the math of things that change.
Section 1. The math of change.
Let's start off by looking at how we actually measure movement in everyday life, and where regular math starts to show its serious limitations. Imagine you're in a car. If you drive a perfectly steady 60 miles per hour for exactly 2 hours, basic math easily gives you the distance, right? 120 miles. It's a super simple multiplication problem. But come on, when was the last time a car trip actually looked like that? Never. In reality, you get stuck behind a slow truck, you speed up to pass them, you hit the brakes for traffic, and you stop at red lights. Your speed is constantly changing minute by minute. The moment that rate of change fluctuates, basic math fails us. We can't just multiply speed and time anymore because the speed won't sit still. We absolutely need a new tool.
Section 2. The limit. Getting really close.
Now, before we unlock the main tool to solve this speeding car problem, we need to understand the single foundational idea that makes all of calculus possible. Without this concept, the whole shebang falls apart. Think of a limit kind of like zooming in on a pixelated photo. Sometimes, in math, if you try to calculate a single exact instant, you end up doing something impossible, like dividing by zero, which mathematically breaks the universe. A limit is an incredibly clever workaround. It asks what picture is forming as we get incredibly microscopically close to that point. We might not be able to land exactly on the dot itself, but by zooming in closer and closer, we can figure out exactly what value it's approaching. It takes the imprecise and makes it perfectly precise.
Section 3. Meet the derivative.
So with limits acting as our foundation, we can finally introduce the absolute star of the show. This is the tool that solves our speed problem and answers our battery life question. Whenever you see the word derivative or hear someone talk about differentiation, I want you to just push away any of that math anxiety and ask yourself one simple question. How fast is this thing changing right now, at this exact moment? That's all a derivative is. It is not about the average speed over a whole hour. It is the instantaneous, exact rate of change right now.
Let's make this super concrete. Picture yourself watching dashcam footage of that messy, stop-and-go car trip we talked about earlier. You hit pause on the video at exactly 3:42 p.m. The car is totally frozen on screen. Well, a derivative calculates that car's exact speed at that frozen frame. It doesn't care at all about your average speed for the whole trip. It takes a mathematical function representing your car's position, and it gives you a brand new function. And this new function acts like a magic speedometer that can tell you your precise speed at any frozen second you choose.
Section 4. Rules are just shortcuts.
Look, if you've ever glanced at a calculus textbook, you probably heard it's just endless, confusing formula memorization. But I'm here to tell you, if you understand what a derivative actually is, those formulas are actually cheat codes. Once you get it that we're just finding the rate of change at a specific frozen moment, these rules stop being arbitrary nonsense. They become logical, time-saving shortcuts so you don't have to calculate limits from scratch every single time. Take the constant rule, for example. It tells us that the derivative of a plain number is 0. Why? Well, because a constant number never changes. Its rate of change is automatically 0. The sum rule just says if you have two things added together, you can find the rate of change for each one separately. See, they're just practical shortcuts to make your life way easier.
And when you see these shortcuts used on an actual worksheet, you can see how fast this builds. By using things like the power rule, where you essentially just bring the exponent down to multiply, you are effortlessly slicing through massive, complex equations in a matter of seconds. You aren't doing the heavy lifting of zooming in with limits over and over again. You're just applying the cheat codes to instantly find the new function that describes the rate of change. It literally turns a massive headache into a quick mechanical puzzle.
These shortcuts also perfectly explain what sounds like one of the most intimidating rules in calculus, the chain rule. When you have functions tucked inside other functions, kind of like nested Russian dolls, you use the chain rule. And as mathematician George F. Simmons explains, it's just basic logic. If a car is twice as fast as a bike, and the bike is 4 times as fast as a person walking, how much faster is the car than the person? 2 times 4 equals 8. You just chain together the different rates of change by multiplying them to get the correct overall rate. I mean, it sounds terrifying on a syllabus, but it is incredibly simple in practice.
Section 5. Real-world superpowers.
So, you might be wondering, why does anyone, especially a 13-year-old, actually need to know how this math works? It's completely fair to ask why we care about limits and derivatives outside of just passing a math test. But the truth is, calculus isn't just a subject you leave in the classroom. It's actively running in the background of your daily life. When your family uses GPS, it's using calculus to integrate your constantly changing speeds to figure out exactly how far you've traveled. When doctors administer medicine, they use derivatives to calculate exactly how fast the drug concentration in your blood is falling. And every single AI system or social media algorithm you interact with on TikTok or YouTube, trained using calculus. They specifically use derivatives to find the lowest possible rate of error to feed you the best possible recommendations.
Calculus is literally the invisible engine powering modern technology. We live in a fast-paced world of constant, unpredictable change. And now that you truly understand the mathematical tool designed to measure exactly how fast things are happening at any given instant, I hope you never look at a speeding car, a complex algorithm, or even just a dying phone battery the exact same way again. If you can measure change, you can predict the future. And in a universe that never stops moving, what will you discover with that superpower?